SD is a post-plot option for generating scatter diagram of 2D plot as function of user-specified SD reference data. For example, the first subplot here shows the RMS tracking at sync frequency 1N during a rotor test. The other subplot are two performance data PD1 and PD2. To generate scatter diagram, first right mouse click on it to show its pull-down list, and select the first option for manual SD. An SD menu will pop up. The list box here display the SD reference data. PC Signal automatically add the RPM profile in reference window into the SD reference list box as shown here. Use these import button to add more data to the list box. Let's click this import all subplot button to import all these three subplot into the list box. The first menu tab is for 2D SD, in which case, the y-axis of 2D SD will be the source subplot data, while the x-axis will be the SD reference data. For example, let's generate 2D SD of the RMS tracking as function of RPM. First click on the RMS tracking to make it the active subplot. Then click on the RPM in list box to select it as the SD reference. In Apply to, turn on Active Subplots option, and click Apply. A 2D SD plot will pop up, showing the 2D SD of RMS tracking as function of RPM. To generate 2D SD as function of multiple SD references such as these three, simply select them in SD reference list box and click Apply. A plot will pop up showing the 2D SD of the RMS tracking as function of RPM, PD1 and PD2. The second menu tab is for multi-dimension SD. First select type of SD, such as 3D SD color, 3D SD, or 4D SD. For example, for 3D SD color, we need to select three data from the list box. First select RPM. Then click Set as X. RPM is now selected as X-axis. Next select PD1. Then click Set as Y. PD1 is selected as Y-axis. Next select RMS tracking. Then click Set as Z. RMS tracking is now selected as Z-axis. If needed, turn on the option for Apply Single Channel Math Operation, e.g. moving average. If the data in list box do not share a common X-axis data, then select time-based channel for interpolation of other channels. Select Start Time and End Time in the source plots for generating the SD. Click Apply to generate. A 3D SD color plot is generated, with RPM in X-axis, PD1 in Y-axis, and RMS tracking in Z-axis, whose amplitude is represented by color legend. To generate a three-dimensional SD plot, select this 3D SD and use the data for X, Y, and Z axis. Click Apply. A 3D SD plot is generated, with RPM in X-axis, PD1 in Y-axis, and RMS tracking in Z-axis. The next option is 4D SD, which require the selection of 4 data in the list box. Click Apply. A 4D SD plot is generated, with RPM in X-axis, PD1 in Y-axis, PD2 in Z-axis, and RMS tracking in W-axis, whose amplitude is represented by color legend. Right mouse click on the plot. More options are available to view the plot. For example, let's select this rotation control. And a rotation control menu will show which allow the user to rotate the 4D SD around the X, Y, and Z axis. For example, let's click on the scroll bar for Z rotation. Click Default to resume the initial position. Another option is the quad chart, which will show a menu for selecting the view angle for the quad chart. Click OK and a quad chart will pop up, showing the 4D SD and its 3-side view from X side, Y side, and from top. The second option in the pull-down list is Auto SD, which will generate scatter diagram of all subplots with SD reference from all subplots. Let's click on the 2D plot to make it the active plot. Then select the Auto SD. 3x3 plot will be generated as shown here. The off-diagonal plot is the 2D scatter diagram of the corresponding row and column. For example, this plot in second row and third column is the SD. Between the second and third source subplot, the diagonal plot is histogram each source subplots. For example, this plot second row and second column is the histogram of second source subplot.